Hello and welcome to Algebra 2 Lesson 29. In this video, we're going to learn about applications of linear systems. So throughout your study of algebra, and I mean Algebra 1, Algebra 2, college algebra, whatever level of algebra you're in, you're going to consistently run into word problems. And for whatever section you're dealing with, they're generally a little bit more challenging than if you just had a problem presented to you. The reason for this is you have to dig through the information and then generate the problem and then solve it and go back and answer and figure out if it makes sense. So in a lot of cases, it will help you substantially if you have just a little procedure, a little guideline to refer to when you're working through these problems. So I'm going to give you one here, and you can make up your own and you can modify this whatever suits your needs. So I have here solving applications of linear systems. So the first thing, and probably the most important thing when you're working any word problem, I don't care what it is, you want to read the problem and determine the main objective. If you don't know what you're being asked to find, then how can you find it, right? So that's the most important thing. All right, the next thing is to assign a variable to represent each unknown. Now this changed a little bit versus when we talked about solving a linear equation in one variable, right? When we looked at word problems for that section, in that case, I have one equation and one variable. If I have more than one unknown, those problems are set up in such a way to where I can express the other unknown in terms of that first one that I said, hey, x is this, then this one is x minus this, or x plus this, or whatever your given scenario is. When we deal with a section on linear systems, in general, the problems are set up to where you just assign a variable to represent each unknown, and then you would write a system of equations. Now, for every unknown I have to have an equation. So if I have two unknowns, I need two equations. If I have three unknowns, I need three equations. If I had seven unknowns, I would need seven equations, so on and so forth. Now, once I've gone through and I've written my system of equations, I would simply solve the system and I want to check. Now, with word problems, you gotta make sure that when you check your answer, it's reasonable, okay? If I'm on a train and it says how many passengers were on this train with me, it can't be -7, okay? That doesn't make sense. If I'm calculating a rate of speed, it can't be -30, okay? That doesn't make sense. If I'm calculating the amount of distance that was driven and it says -2.6, that doesn't make sense. So make sure that your answer is reasonable, okay, in terms of the problem. All right, so let's take a look at the first example. So we have that Beth's school is selling tickets to a fall musical. On the first day of ticket sales, the school sold 12 senior tickets and 16 child tickets for a total of $336. The school took in $312 on the second day by selling 15 senior tickets and 11 child tickets. Find the price of a senior ticket and the price of a child ticket. So it's very straightforward here what we need to do. We want to what? Find the price of a senior ticket and the price of a child ticket. So we find the two things that we don't know. And for each unknown, we represent with a variable. So let's go down to the next page. So we will let x be equal to the price of each child ticket. And then y will be equal to the price of each senior ticket. All right, so now we want to go ahead and write a system of equations. So let's go back through our little problem. We're going to read and gather some information that we can use to set up a system. So with these problems, they're going to give you information to build your system. With this one, it tells you about ticket sales. So on the first day of ticket sales, the school sold 12 senior tickets and 16 child tickets for a total of $336. So let me go to the next page. So there was 12 senior and 16 child, and it was $336. Let's just save that information there. Let's go back. Now, the other scenario they give us, it says the school took in $312 on the second day by selling 15 senior tickets and 11 child tickets. So let's go back. So now we have 15 senior. We have 11 child. And the total from this day was $312. So I have two scenarios, and this is going to be enough for me to build a system of equations. So X is the price of each child ticket. Now, if I sold 16 child tickets, and X is the price of each child ticket. So let's say X was 10. I'm not saying it is, but let's say it was. Well, 16 times 10 would be 160. So I need to multiply 16 times X to get the total revenue from selling child tickets that day. So in the first scenario, I will have 16 times X. Then I've got to do the same thing for senior tickets. So plus 12 times Y. And this is equal to 336. So this is my first scenario. My second scenario over here, I'm going to mirror that. It's going to give me my second equation. So for child tickets, it's 11 that we sold times X dollars a piece. Plus, for senior tickets, it's 15 sold times Y dollars a piece. And this equals 312. All right, so let's go through this real quick just so everybody understands what's going on. This 16, this number here, and this 11 here, that's how many we sold. So that's a quantity. The X represents the price per ticket. So if I have the amount sold times the price each, that gives me the total revenue, in this case for child's tickets sold. Then I have 12 and I have 15. Then each one is multiplied by Y. So in this case, it's 12 times Y. In this case, it's 15 times Y. That's giving me the revenue for senior tickets sold. If I take the revenue from child's tickets sold and the revenue from senior tickets sold, and I combine them together, I should get the total revenue for the day. So here, that total revenue was 336. Here, that total revenue was 312. So that's how we went about setting up our system of equations. And now it's just a matter of solving the system for X and Y, and we can report our answer. We'll know X is the amount per child's ticket sold, and Y is the amount per senior tickets sold. All right, so let's go ahead and use substitution. I think that'd be a little bit easier here. So I'm going to take equation 1, and I'm going to solve it for Y. So I have 16X plus 12Y is equal to 336. So let's subtract 16X away from each side of the equation. This would cancel. I'll have 12Y is equal to negative 16X plus 336. The next thing I want to do is I want to divide both sides of the equation by 12. So this will cancel. I'll have Y is equal to negative 16 over 12. We know that's negative. 16 and 12 are each divisible by 4. So if I divide 16 by 4, I get 4. If I divide 12 by 4, I get 3. So this would be negative 4/3 X. And then 336 over 12 is 28. So this would be plus 28. So I have solved equation 1 for Y. So now I'm going to plug in for Y in equation 2. So here's Y. And I'm going to plug in. Remember, Y is equal to, or Y is the same as, negative 4/3 X plus 28. So this will get plugged in here. And then I'll have a linear equation in X. Okay, I'll just have one variable. So 11X plus 15. Now I'm going to substitute in the negative 4/3 X plus 28, like that quantity. And again, make sure you use parentheses because 15 is multiplied by this whole quantity. And this equals 312. So I will have 11X plus, I'll do 15 times negative 4/3 X plus 15 times 28 equals 312. Now let's deal with this. So 15 times negative 4/3, 15 would cancel with 3 and give me 5. 5 times negative 4 is negative 20. So this would be 11X minus 20X plus 15 times 28 is 420. And this equals 312. All right, scroll down and get a little bit of room going. So 11x minus 20x, we know that's negative 9x. So let's write negative 9x. Let's subtract 420 away from each side of the equation. That'll cancel. So negative 9x is going to be equal to 312 minus 420 is going to give me negative 108. So let's go ahead and divide both sides of the equation by negative 9. So this will cancel with this, and I'll have x is equal to 12. All right, so now that I know x is equal to 12, let's erase everything. Let's go back up here. I can erase this. So x is equal to 12. So I can plug a 12 in for x either in equation 1 or 2, doesn't matter, and solve for the unknown y. Let's go ahead and plug in a 12 for x in equation 2. So I would have 11 times 12 plus 15y equals 312. 11 times 12 is 132. So I'd have 132 plus 15y is equal to 312. Let's subtract 132 away from each side of the equation. That's going to cancel. We'll have 15y is equal to 312 minus 132 is 180. So let's go ahead and divide both sides of the equation by 15. And we'll find that y is equal to 12. So x and y are the same value. They're each 12. So remember, x was the price of each child ticket, and y was the price of each senior ticket. They're each 12, so we can go ahead and answer and say that each senior ticket and each child ticket sold for $12. Now, can we verify this? Yeah, quite easily. If on the first day we sold 12 senior tickets and 16 child tickets, well, since the price is the same, I might as well say, okay, well, I sold a total of 12 plus 16, or 28 tickets. Now, if I took the 28 tickets I sold and I multiplied it by a price of $12 each, the total amount that would be received is $336. So that one checks out. Then in the other scenario, the school took in $312 by selling 15 senior tickets and 11 child tickets. So 15 plus 11 is 26. So 26 total tickets that day. And they're again $12 a piece because a senior ticket and a child ticket both sell for $12. So 26 times 12 would give me 312. Right? So they would have taken $312 in that day. So the answer is correct here. Each senior ticket and each child ticket sold for $12. All right, so for the next problem, a boat traveled 45 miles downstream and back. The trip downstream took 3 hours, while the trip back took 5 hours. Find the average speed of the boat in still water, along with the speed of the current. So what do we need to focus on here? Well, there's two things. We want to find the average speed of the boat in still water, meaning if there was no current, how fast would the boat go? And then also the speed of the current. So we would start by just assigning a variable to each of those. So a variable to the speed of the boat in still water and to the speed of the current. So let's go down. Let's let x be equal to the speed of the boat, and this is in miles per hour, in still water. Okay, then y would be equal to the speed of the current. So the speed of the current. And again, this is in miles per hour. All right, let's go back. Now, in order to answer these two questions, we want to think a little bit about what's going on here. So the boat traveled 45 miles downstream and back. Downstream means you're going with the current. If you're going with the current, you're going to go faster. Just think about taking like an inflatable raft and just putting it in the water and going with the current. Even though you don't have a motor or some kind of propeller to move you, you're being moved by the current. So the current has a general speed that it's going to push you at. Now, if you're going upstream, you're fighting the current. You know, have you ever been in a rowboat or anything, or even a simple boat, and you're trying to fight the current? It's very hard because you're dealing with a force that's pushing against you now. So the trip downstream took 3 hours, while the trip back, which would be upstream, took 5 hours. So of course, if you're going downstream, if you're going with the current, it's going to take you less time because you have a little helping hand. So thinking about this, let's go back down. This is a motion word problem. So for a motion word problem, we think about the distance formula, right? Distance is equal to the rate of speed times the amount of time traveled. And a lot of times when we have a motion word problem, it's usually easiest to just use a little table. So you have two scenarios. The first one would be downstream. The second one would be upstream. So you have your distance, and that's equal to the rate times the time. So let's see if we can fill in this information. So downstream, when we're doing our trip, let's go back up. The boat traveled 45 miles. So that's the distance. So downstream and back. The trip downstream took 3 hours. Let's just stop there. So we're given a distance of 45 miles. So we know that. 45. The rate of speed, we're not given. We can use our variables to work with that. But the time we are given. For the trip downstream, we're told the time is 3 hours. So we have that. So for the rate, if I'm going downstream, I have the speed of the boat in still water. So if there was no current at all, that's x. And I also have the speed of the current that's helping me, right? So I would increase the speed by that amount. So x plus y would be my rate of speed here. So this times this would give me this. Now for upstream, it tells us what? Well, the distance is the same. The only difference is the rate of speed and the time. The time now is 5 hours. Let's go down. So the time is 5. The distance is 45. The rate of speed is going to be different here. You have the speed of the boat in still water, but since you're going upstream, you're now fighting the current. So you have to subtract away y. Okay, you have to subtract away y. And the reason for that is your boat is fighting. Okay, you're in the still water, you have a certain speed. If you all of a sudden get put against the current, you have to subtract away the speed of that current. So as an example, if I was going 6 miles an hour in still water and the current was 3 miles an hour, well, if I'm fighting the current, then now I'm going 6 minus 3, or 3 miles an hour. So that's where we get this calculation here. Now, I have a linear system in two variables if I look at my little table. Again, a distance is equal to a rate of speed times a time. So for downstream, I have this. Let's label this equation 1. We have 3 times the quantity x plus y is equal to 45. For equation 2, I would have 5 times the quantity x minus y is equal to 45. Now, for this system, it's going to be really easy to use substitution. Inside the parentheses, you see you have plus y and minus y. So the way we're going to do that, let me just kind of move this over here. If I have 3 multiplied by the quantity x plus y, and this is equal to 45, I can divide both sides of this equation by 3. Again, this is multiplication, so this would just cancel. So then I'm left with x plus y is equal to 45 over 3 is 15. So this I could write as x plus y equals 15. Then for this one, I could do the same thing. So if I have 5 times the quantity x minus y equals 45, I can divide both sides of the equation by 5. This will cancel. I'll have x minus y is equal to 45 over 5 is 9. So if I add the left sides together, set that equal to the sum of the right sides, x plus x is 2x, y plus negative y or y minus y is 0, 15 plus 9 is 24. So now I divide both sides of the equation by 2, and I get that x is equal to 12. All right, so let's erase all this. We know x equals 12 at this point. So what is y going to be? So x equals 12. So let's plug that back into, let's say, equation 2. So we'd have 5 times the quantity. I'd have 12 minus y. This equals 45. 5 times 12 is 60. So you'd have 60 minus 5y is equal to 45. We would subtract 60 away from each side of the equation. That would cancel. You'd have negative 5y is equal to 45 minus 60 is negative 15. Divide both sides of the equation by negative 5, and you'll get y is equal to 3. So x is 12, y is 3. So I want you to remember that x is the speed of the boat in still water, y is the speed of the current. So we can say that the speed of the boat in still water was 12 miles per hour. The speed of the current was 3 miles per hour. And we could check this pretty easily. The trip downstream took 3 hours. Okay, so remember, distance equals rate times time. So if I'm going downstream or with the current, again, I would take my rate of speed in still water, which is 12 miles per hour. I would add the speed of the current because it's pushing me or helping me by that much. So 12 plus 3 is 15. So I'm going 15 miles an hour for 3 hours. That means I went 45 miles. So this one checks out. Now the trip back, we think about that. You're going 12 miles an hour in still water. Now you're fighting the current, so you've got to subtract away what the current speed is. So 12 minus 3 is 9. So now we're going 9 miles per hour for 5 hours. That's 45 miles. So that one checks out as well. So again, the speed of the boat in still water was 12 miles per hour, and the speed of the current was 3 miles per hour. All right, let's wrap up our lesson with one that's a little bit more tedious. So James won $86,000 in the local lottery. He decided to invest the whole amount in 3 different investment funds. One, a REIT, which stands for Real Estate Investment Trust, pays 6% annual simple interest. So remember, with simple interest, you don't get interest on top of interest. So the others, a CD, certificate of deposit, and a bond fund, pay 2% and 3% respectively. So that means that the CD pays 2%, the bond fund pays 3%. The total in annual simple interest from the 3 investments was $3,900. The annual simple interest earned from the REIT was $900 less than 3 times the amount earned from the bond fund and the CD. Find how much was invested in each. So this is kind of a long problem with a lot of information. And when that happens, you tend to get lost in the mix. I just want you to focus on one thing at a time. So the first thing is, what are we asked to find? We're asked to find how much was invested in each. There are 3 things here. There's a REIT, there's a CD, and there's a bond fund. And we're not given any information as far as how much was invested in each one, so we could use a variable to represent each amount. So we could say X, let X be equal to the amount invested in the REIT. Again, that's a real estate investment trust. Then we could say Y would equal the amount invested in the CD or certificate of deposit. Then we could say Z is equal to the amount invested in the bond fund. Okay, so now we've represented these 3 amounts with variables. So we find out what X is, find out what Y is, we find out what Z is, and we've answered our problem. But when you have 3 unknowns, you've got to have 3 equations to figure them out. Okay, 3 unknowns, you need 3 equations. 4 unknowns, 4 equations. 17 unknowns, 17 equations, so on and so forth. So let's go back through the problem and see if we can figure out 3 equations. So the first one would come from this. James won $86,000 in the local lottery. he decided to invest the whole amount. So all of it, that's basically telling me that $86,000 is going to be involved here, in 3 different investment funds. So between the REIT, the CD, and the bond fund, there's a total of $86,000 in them. So that tells me that if I sum X, Y, and Z, that's going to be 86,000. So for equation 1, X plus Y plus Z is going to be equal to 86,000. And again, that's straight from the problem. The amount invested in the REIT plus the amount invested in the CD plus the amount invested in the bond fund, because he only puts money in those 3 areas, is going to sum to $86,000. All right, let's see if we can get another equation. All right, so the next thing we see, we have a REIT pays 6% annual simple interest. The others, a CD and a bond fund, pay 2% and 3% respectively. Let me write that down here real fast. So let's put that this one pays 6%, this one pays 2%, and this one pays 3%. Okay, let's go back up. Now, the next part is where we're going to get our next equation. The total on annual simple interest from the 3 investments was $3,900. Okay, so let's stop. Now, if I had one investment with simple interest, what is the simple interest formula? Let me do this on a little sidebar over here. Well, the simple interest formula, in case you don't know it, is the simple interest earned, which is I, is equal to the principal or amount invested times the rate times the time. Now, in this particular case, we're talking about annual, so that's 1 year. So if time is 1, if I'm multiplying by 1, it doesn't change, so I can just get rid of this. But think about just principal times rate. Now, the principal or the amount invested in each case is listed with a variable. So if I take the REIT, for example, that would be X. Now the rate I'm given is 6%. You got to write that as a decimal, so that would be 0.06. So let's rearrange this and put 0.06. So then times X. So I'm not given the simple interest earned for just the REIT. So this 0.06x equals I. I don't know what I is for that. What I know I for, or the 3,900, is this guy, the REIT, plus the CD, plus the bond fund. So my equation would be 0.06x plus, the CD pays 2%, so 0.02y plus, the bond fund pays 3%, so 0.03z. And let me erase all this. This would be equal to 3,900. And again, this comes from the simple interest formula. I have a 6% interest rate times an amount invested of X for my REIT. So if I multiply these two together, I'm going to get the amount of interest that's earned from the REIT in 1 year. I add that to the amount of interest that's earned from the CD for 1 year. I add that to the amount of interest that's earned from the bond fund for a year, and the total, as it's told to me in the problem, is $3,900. So this is my equation 2. Let's see if we can get a third equation. So we're told here that the annual simple interest earned from the REIT. So let's stop. What was that? Well, we just saw that we put 0.06x for that, right? 0.06 is 6% as a decimal. It's multiplied by X, which is the amount invested in the REIT. That would give me the amount of simple interest that the REIT earns in a year. So that's going to be 0.06x. So this was, or in terms of setting up an equation, means it's equal to, we have $900 less than 3 times the amount earned from the bond fund and the CD. So let's start with what's earned from the bond fund and the CD. Well, the CD and the bond fund we have with these two amounts. So we can put 0.02y plus 0.03z. Now it's 3 times this amount, so 3 times this quantity, and it's 900 less than that. So subtract away 900. This would be my third equation. Let's go back up and make sure this makes sense. So again, and this is a little complex, the annual simple interest earned from the REIT, which is 0.06x, was $900 less than 3 times the amount earned from the bond fund and the CD. So we have 900 less than, subtracting away 900 there, This is the amount earned from the bond fund and the CD, and we have 3 times that amount. All right, so that's where that equation came from, and now we're ready to roll. Okay, so it might take you a little while to get these 3 equations when you first start. You got to read through that problem very carefully, but I can assure you if this is in a textbook or on a test, the information is enough to get you the equations you need. They set it up that way. But sometimes it's not so straightforward what you need to do. So how do I want to solve this system? In most cases, with 3 equations, 3 variables, we eliminate a variable, and then we solve a system in 2 variables, and then we come back and we figure out the third. So let me just start with equation 1 and equation 2. So equation 1 is x plus y plus z equals 86,000. Equation 2, we have 0.06x plus 0.02y plus 0.03z equals 3,900. Now to make this easy, I can multiply both sides of this equation by 100. Every decimal point would go over to the right by 2. So this would be 6x plus 2y plus 3z equals, so in this case it'd be 2 zeros at the end, so 390,000. So we would have 6x plus 2y plus 3z equals 390,000. Okay, so now if I wanted to use elimination here, what I would do is just choose a variable. Doesn't matter what I choose. Let's go ahead and just choose y. So if I want y and 2y to be opposites, what would be easiest to make this negative 2y? So let's multiply both sides of the equation by negative 2. So negative 2 times x is negative 2x. Negative 2 times y is minus 2y. Negative 2 times z is minus 2z. This equals 86,000 times negative 2. That's negative 172,000. Let's erase this now. We don't need it anymore. So I can add the left sides together. Set this equal to the sum of the right sides. So 6x minus 2x is 4x. 2y minus 2y, this is eliminated. 3z minus 2z is z, so plus z. 390,000 minus 172,000, that's going to give me 218,000. So this would be equation 4. Let's write this on a new sheet. So equation 4 is 4x plus z equals 218,000. All right, let's go back up. All right, now let's work with equation 2 and 3. And again, we've got to eliminate the same variable this time, so we've got to eliminate y. So for equation 2, I have 6x plus 2y plus 3z equals 390,000. For equation 3, it's a little clustered. Let's kind of clean it up. So 0.06x equals 3 times 0.02 is 0.06, then times y, plus 3 times 0.03 is 0.09, then times z, then minus 900. Now again, I can clear the decimals by multiplying everything by 100. So this would go 2 places to the right, that would be 6x. This goes 2 places to the right, it'd be 6y. This would be 9z. And I'd put 2 zeros at the end here to give me 90,000. So I can erase this. And let me just write it in this format. So I'd have 6x. Let me subtract away 6y from each side. Let me subtract away 9z from each side. And this will equal negative 90,000. Okay, so let me erase this. And so I'll write 6x minus 6y minus 9z is equal to negative 90,000. All right, so if I want to eliminate y, the easiest thing I can do, since I have negative 6 here and 2 here, I can multiply 2 times 3 and get positive 6. Positive 6 and negative 6 are opposites. So I'll multiply this by 3, and the same thing on this side. 3 times 6x is 18x. 3 times 2y is 6y. 3 times 3z is plus 9z. And this will be equal to 3 times 390,000 is 1,170,000. All right, so let's erase this. And let me scroll down a little bit, get some room going. So let's sum the left sides, set it equal to the sum of the right sides. So these are going to cancel. 6x plus 18x is 24x. And this equals negative 90,000 plus 1,170,000 is 1,080,000. All right, so let's copy this. So that'll be equation 5. Let me kind of tighten this down a little bit. So it's pretty easy. We're just going to solve this equation 5 for x. So we would get x is equal to 45,000. Now we're going to plug 45,000 in for x in equation 4. So I would have 4 times 45,000 plus z is equal to 218,000. 4 times 45,000 is 180,000. Plus z equals 218,000. Scroll down and get a little room going. Let's go ahead and subtract 180,000 from each side of the equation. That'll cancel. We'll have z is equal to 38,000. All right, so now I know x is 45,000. I know z is 38,000. So we know z is 38,000. X is 45,000. Let's just plug that into equation 1. So we'd have 45,000 plus y plus, for z, 38,000. This equals 86,000. So if I had 45,000 and 38,000, I'd get 83,000. So you'd have y plus 83,000 equals 86,000. Go ahead and subtract 83,000 away from each side of the equation. Y is going to equal 3,000. So y equals 3,000. Okay, so now I want you to remember what x, y, and z represent. X is the amount invested in the REIT. Y is the amount invested in the CD. Z is the amount invested in the bond fund. So let's take this up. We're going to say there was $45,000 invested in the REIT with $3,000 invested in the CD and $38,000 invested in the bond fund. Now again, if you check this, you think about James invested $86,000 total. So is that consistent with what you found? Well, 45,000 plus 38,000 is 83,000, plus another 3,000 is 86,000, so it checks out there. Now the next thing is the total annual simple interest from the 3 investments is $3,900. Does that work out? Well, from the REIT, you've got $45,000 invested at 6%. That's $2,700 in interest. In the CD, it's $3,000 at 2%, so that's $60. And then if you take the bond fund, that's $38,000 at 3%, that's $1,140. So if you add $2,700 plus 60, you would get $2,760 plus $1,140. You do in fact get $3,900, so it checks out here as well. Now the last one, it says the annual simple interest earned from the REIT, which is $2,700, was $900 less than 3 times the amount earned from the bond fund and the CD. So from the bond fund, he got $1,140. From the CD, he got $60. So combine those two amounts together, you get $1,200. So again, it was $900 less than 3 times the amount of $1,200. 3 times $1,200 would be $3,600. 3,600 minus 900 would be 2,700. So that one checks out as well. So a very tedious problem overall. Takes a little bit of time to get into it, takes some time to set up, and takes some time to check it. But worth it in the end, because you've got to see a few of these, because if you get them on a test, you can't just be, completely rattled. Okay, you've had some experience now in dealing with one of these really tedious problems. So again, to just state the answer, there was $45,000 invested in the REIT, with $3,000 invested in the CD and $38,000 invested in the bond fun.